Hi, my name is Aishi Jang, and today I'll be covering two questions related to the concept video on the four emergent properties of water. Question 1. What kinds of bonds are broken in the vaporization of water? A. Ionic bonds, B. Hydrogen bonds, C. Both polar covalent bonds and hydrogen bonds, D. Polycovalent bonds, and E. Both hydrogen bonds and ionic bonds. Take a few seconds to think about this question. If you said B, hydrogen bonds, then you are correct. Now let's go through some of the other answers. Ionic bonds is wrong because for an ionic bond, you need oppositely charged ions, and water is actually not an ion, although it has the dipole. The oxygen end only has a partial negative charge, and the hydrogen end has a partial positive charge. Now the other answer has to do with polar covalent bonding. And I guess what this assumes is that as water is being converted from liquid to gas, the bonds between the oxygen and the hydrogen are being broken. This is not the case. What happens when water is converted from liquid to gas is that the space between the water molecules increases. So the polar covalent bond is actually intact. Therefore, the answer is B. Question 2. Liquid water's high specific heat is mainly due to A. Water being a poor heat conductor, B. The higher density of water compared to ice, C. Absorption and release of heat when hydrogen bonds break and form, and D. High specific heat of oxygen and hydrogen atoms. Take a few seconds to think about this question. If you answered C, absorption and release of heat when hydrogen bonds break and form, then you are correct. Let's go through some of the other answers. A. Water being a poor heat conductor. Well, first off, water is actually a pretty good heat conductor. But what else is wrong about this answer is that being a good heat conductor and having a high specific heat are two different concepts. Being a good heat conductor means that the material can allow heat to flow through it very easily. But having a high specific heat means that it takes a lot more energy to cause an increase in temperature. Now let's look at B, the higher density of water compared to ice. Well, water's high specific heat has very little to do with its higher density. I'm guessing what this answer is trying to get at is the idea that having a higher density means having high specific heat. This is not the case because if you look at the unit that specific heat is measured in, it's in calories per gram per degree Celsius. It's about the amount of mass of water that's there, not the volume. Now let's look at D. High specific heat of oxygen and hydrogen atoms. Now, although the individual atoms of a molecule do have an impact on the specific heat of the molecule, in water's case, it's mainly because of the dipole that's formed when these three atoms are put together that's the cause of the high specific heat, because this allows for the hydrogen bonding that occurs. And as we covered before, the hydrogen bonding is what essentially accounts for many of water's emergent properties.